Hello and welcome to the video tutorial on the jupyter-connect feature of the virtual eye lab as part of HumaneAI Net. My name is Martin Wels, I work for Fraunhofer in Germany. So the jupyter-connect feature is part of the virtual lab, which is incorporated into the AI for Experiments subsystem of the AI on-demand platform. And AI for Experiments offers a catalog and visual composition possibilities to create pipelines from reusable AI tools. And it has connections to execution environments. So we have already available the public AI playground. It can be deployed to private Kubernetes and also can be run on laptops and PCs. So the jupyter-connect feature is implemented for single models. So the user has to choose a single model from the catalog, then deploy for execution in the menu. So it's really just one click to activate this feature. And then the virtual lab creates all necessary plumbing. So the Jupyter lab container, the shared folder, all communication stubs based on the protobuf definition of the interface of the container and gRPC code generation, and also a ready-to-use Jupyter notebook. So we see here the connections on the right-hand side. The model will be in one container. There will be a separate container, will be the Jupyter Lab node, and then connected to both of them is the shared folder, so that both nodes can access files in a shared folder. There are several use cases for this feature. I will start with the exploration use case. It is meant to quickly check out a model, to choose a model and deploy it as Jupyter Connect, to explore it, connect to the web UI, so typically a browser interface, and explore further the model using the notebook, using the generated gRPC stubs. And it's possible to save the notebook locally for later, so locally on the PC of the user, so it can be used in later instances or in different setups. Then there is the training use case. Here the model needs to expose a training method in the protobuf interface. Then the training data needs to be loaded into the shared folder using the notebook, and then it's possible to start the training via the gRPC stubs from the notebook, from the Jupyter notebook. Then the user can, of course, watch, explore and analyze the results. And finally, if all went well, it's possible to save the model also locally, so that it can be used later. Then there is the first education use case about teaching. So in this case, the lecturer chooses an AI model from the catalog and deploys it for execution, for example, in the playground using Jupyter Connect. And then the lecturer can give a live demo and interaction during the lecture, and also save the notebooks then for later distribution among the students for reference. Then there is the second education use case, the student lab. In this case, the instructor chooses AI tools from the catalog, and each student deploys the model as Jupyter Connect. And then each student, as a result, has a personal environment, and then the prepared tasks can be solved in the Jupyter notebook, and each student can work then individually or in teams on the tasks and submit the notebook to the instructor for assessment. And then last but not least, we have the certification use case. It is meant to deploy a model for certification. Then the actual certification steps are done in the Jupyter notebook, and after that the notebook can be saved and digitally signed by an authority, and thus the notebook can work as a proof and protocol of the certification. Okay, now let's dive into a live demo. So here's the AI for Experiment system, and we choose for our live demo the sentiment analysis model in the catalog. And here we go on deploy for execution, and we choose the AI Lab Playground, which is publicly available, so everybody can try it out. And just with one click it gets deployed. It takes a couple of seconds. And now we are in the AI Playground, and we see the deployed containers. So we have the sentiment analysis model, we have the jupyter-connect, the Jupyter Lab container, and we have the shared folder for common files. So then we connect to the web UI of the jupyter-connect node, and here we see Jupyter. And we open the example notebook, and it has already automatically included in this notebook the protobuf definition of the model we chose. So here we see the sentiment analysis model, and we see here the classify review method is the one that we can use, and it takes a text message which is specified here as an input. Okay, so then we execute the notebook cell by cell. Here are further instructions with examples how to actually use it, and here in this one then we need to create the message we want to send. So in this case we have a text, and the parameter that we need to set is the query, I think. Yeah, so the query string needs to be set, and this can be the movie was awesome. Then we run this. Now we have the request message created, and in the next cell we can then actually send the request. So we can click on tab for automatic completion, and we send the request message. So this has been successful, and we print the response. And the response here is the prediction of the sentiment assessment, and it's close to 1, so it is a positive review. And then let's have a look at the web UI of the sentiment analysis model. So we open this also, and here we can see that actually our query was received, and we see also the result. So we really communicated with the sentiment analysis container here. Okay, so this concludes my video tutorial. I hope it will be useful for you, and talk to you in the next tutorial. Bye bye.